Hi guys, welcome back. On request, I have made a movie about the kinetics. So we're going to talk about rate of reaction. As I told you earlier, collision model. So we can explain the reaction with the collision model. For an effective collision, we can say that's a reaction, particles need to have the right direction and the right speed. So molecules, they collide with each other, and that's what we call chemical reaction. And the molecules need the right speed and direction. You can see it in this picture here. Molecules before, and then we have the collision when they have the right speed and direction, and after the collision the molecules atoms are rearranged, and then we have a successful chemical reaction. There are a couple of factors that influence the rate of the reaction. First, type of reactant. Some will react, some will not. It's just a characteristic of the reactant. Surface area. Higher, larger surface area, more possibilities for collisions, so for reactions. Concentration number 3. More particles, so higher concentration, more possibilities for collisions, more possibilities for reactions, increase rate of reaction. Temperature. Higher temperature means more speed of my molecules. So they have a higher chance to collide with each other because they have a higher speed. So higher temperature, increased rate of reactions. And then finally, a catalyst. A catalyst particle that's not part of my reaction. It's not in my reaction equation, but it makes the reaction possible or increase the speed. So as said, there's a cartoon on a boy and a girl want to go to the dance and explain the 5 different factors for chemical reaction as well. So then we talked about rate of reaction with symbol S. We can calculate that. And the rate of the reaction, that's the number of moles of a compound that is formed or reacted per second in a volume of 1 liter. Or it's the change of my concentration in a certain time period. And S is always expressed in moles per liter per second. I had an example here. 2 SO2Cl decomposed to 2 SO2 and Cl2. For 5 minutes, I have 0.018 moles of Cl2 in a 150 liter vessel. Calculate the reaction rate. Well, the change in concentration over time. Concentration. Moles over liter, 0.018 divided by 150, and it happened in 300 seconds. And here I have my reaction rate, unit moles per liter per second. Other example, 10 liters vessel, and then I have the following reaction, NO plus O2 becoming 2NO2. And after 120 seconds, it appears that there is 0.01 mole of NO2. So the rate for this reaction, we do it again. The number of moles divided by the volume, that's the molarity, per 120 seconds, but now you see times 1.5. Why is that? Because there is a 2. So we said we're going to divide with the reaction coefficient for my balanced equation. Why is that? If I have information from O2, I could have a different reaction rate. And when I have a reaction, my reaction rate is the same for all my different particles in my reaction. So the disappearance of O2 is the same as the production of NO2, the same reaction rate. So that's why we divide with the reaction coefficient. Next topic was reaction rate and rate law. So we saw that the concentration was one of the 5 factors. And we can express that by a rate law. And a rate law, S, there we have it again, that's the speed of the reaction, moles per liter per second, is K, that's a rate constant, times the concentration of my 1 or 2 reactant before the reaction starts at T is 0. And the dimension of K can vary. Depends on my rate of my reaction, the rate law. If I have S from A to B, I have S is K times the concentration of A. Because this is mole per liter, this is mole per liter per second for S, so K is 1 over second. If I have 2A to B and my rate law would be K times A squared, then K has a different unit. You can see it here. And for 2A plus B, a possible rate law could be S is K times A squared times B. But is that possible? Because the real rate law we have to find with experimental data. But first of all, I want to look what's going to happen if I double the concentration of A. So we can see it here. If A doubles, so times 2, my S will double, 2 to the power of 1. If A doubles in the second situation, is 2 times 2 to the power of 2 is 4. So S goes up by factor 4, quadruples, 2 to the power of 2. Here the same, because it's a squared times b. I only have information on a. If a doubles, the rate goes up again by factor 4. So you see the 2 here, you find it here as well for the rate. So now we're going to find the order of my reaction. If this is the rate law, S from A to B, and S is K times the concentration of A to the power of 1. It's first order. You see first order, that's the 1. Only depends on one reactant. This reaction, where it has a rate law of K times A squared, we call it second order. Second order because of the square over here. And this rate only depends on one reactant, but to the power of 2. For this one, it's A squared times B, so my overall is a third order reaction. It's second order for A, the 2 over there, and first for B. And it depends on 2 reactants. So the rate order, we're going to play with it Monday. If my concentration of A doubles, but the rate is constant, so it's nothing going to change, we call it zero order, because when we double, 2 to the power of 0 is 1, constant. If my concentration of A doubles and the rate doubles, we call it first order, because I'm going to double, so it's 2 to the power of 1 from first order is 2. If my concentration of A doubles and my rate goes up by a factor of 4, we call it second order, because doubling 2 to the power of 2 is 4. If I triple my concentration of A, so the 3 here, and my rate increased 9 times, it's also second order, because 3 to the power of 2 is 9. So we're going to play with it on Monday, because to assess the order of the reaction, we have to use experiments, experimental data. We cannot assess in theory, but to really find my order of my reaction, we have to use data from experiments. And we continue that on Monday. So the homework for Monday, study notes, and there's an online worksheet on Schoology that's due on Monday. And we talked about it on next Friday. We have a chapter 70 test, including the kinetics and the. All right, guys, that was it. See you again on Monday. Bye-bye.